Hi, this is our last week, but it's not our last meeting. Unfortunately, we have to do some makeup. But I guess after this class, you should be able to do the last assignment I give you, which is just, if you look at the black box, which just released now. I put the here. I give you almost 3 weeks. You can do that. Suppose you should do it by your own, okay? So it's just 5 page. Yeah. You have 4 weeks or so, 3 weeks or so, and I guess most of them are pretty straightforward. Except some calculation for this one, slightly a little bit more complicated, but otherwise everything should be, I expect you to know it from this class. So no tricky question, everything is, I think is very straightforward. But by doing it, you know how to work out the thing I want you to know from this class. So possibly want to share with you, besides the final assignment I expect to do, this means that this also serves as part of your assignment or the final. But the assignment is that there is no more assignment. This is your final assignment. Of course, remember, beside this, you have your project to submit as well. Okay, so that is also very important learning. Didn't invite them? Okay. Oh, for those who just joined, just let you know, I just released the final assignment for this class, which is in a blackboard already. So you can take a look, and please remember this is your take-home exam. So you shouldn't discuss with your friends. Okay, do it on yourself because it's part of your assessment. But you have 3 weeks to do, so I guess no one's a time constraint. It's not something tricky question. Every question is pretty much straightforward, calculation style. Okay, there's no proof, but I want you to calculate. Okay, shouldn't be difficult. So the goal of today is to talk about the topic 7. Okay, static game of income information. That will mostly what we need. Next Monday, we'll talk about the dynamic of confirmation as a makeup. That will be more technical. And this Wednesday afternoon, in FYB, okay, I think just next to this building, we have makeup. You can decide join or not join, because that one I will talk about contract theory. So talk about moral hazard, adverse selection, lemon market, some economic design, I guess, that kind of work. And December 4th, I haven't decided what to cover yet, but depends on how fast we go for the first makeup, and we decide what to cover for that one. Okay, and there is another makeup on December 5th, but the TA haven't set the time. I haven't figured out the book room yet, but once they book, I will tell you. But this class, Wednesday, I'll cover moral hazard, adverse selection. So for those who do account, finance, or whatever, they will learn it in their own course anyway. So even if I don't cover it, it doesn't really lose too much, but I want to cover them because I think it's very useful. And this class, I haven't decided what to cover, but possibly I will cover some axiomatic study, which also I recently doing, and I try to tell you what are those. But that would be the thing. I mean, December 5th, I haven't have the, but we know the time, right? It's 2:50 to 5. But I will let you know. So I hope that it's okay. So very quickly that let us continue. Okay. I just spend very quickly talk about review what we have done because last time we are a little bit fast on this one, okay? So just remind you what we do dynamic game of complete information. Just one thing is Nash equilibrium not sufficient, okay? We need to do subgame perfect, what we call barrier induction. So very often, for my case is, this is type of game is the most common game I solve, right? You have agents or players playing with each other over time, over multiple period. So usually what you do is you solve it from the very end, last period and backward, right? Finite period game. And one of the main problem of solving this is when you have more than one period is the game becomes so complicated to solve, okay? And actually you try to read some game theory textbook because of subgame perfection, which imply that you will solve the last period, you put back the best response to the previous. If the last period is a unique equilibrium, that's easy to solve, right? If the last period is a multiple equilibrium, then how can you go back can be very complicated. And the optimal decision, the last period, can be a complicated function. When you put it back to the previous period, it can be very complicated. So one way that I learned from, I think, 10 years experience would be you have to decide what equilibrium to pick in the last period, okay? You have to figure out the way to select equilibrium. How to select equilibrium, as I said, is a last stage, right? So how you pick is based on what you learn from the topic 5, right? Topic 5 tells you how to pick equilibrium, okay? Sometimes you would say, take away weakly dominant strategy, or you do Pareto dominance, or you kind of stronger equilibrium concept, right? Or we have used player-specific optimal equilibrium. That's often happen in business journal. You focus on the case where it is firm optimal, or consumer optimal, or the guy with stronger market power, which you think is focused on those equilibrium. In that case, you make your solving solution much easier. So that would be my experience. I think that would be a useful thing to you, hopefully, okay? And at the very last, we just skim over the very last thing. I just want to give you a little bit 5-minute talk on that. But this is talk about, basically it's a game theory, right? We talk about the Fogg theorem. We said if players are patient, any outcome is possible. By any, we means if the traditional Fogg theorem means everything beyond Nash would be supportable, right? Because whenever you deviate, you go back to Nash, right? As long as you're patient enough, this can be supported, right? Because the punishments go to Nash, right? Nash by itself is stable, okay? And if you recall the very last one, we talk about actually is more generalized. You can journal to that. If anything that we can make it to the case, any payoff that more than what we call reservation payoff, which means that the maximum you can guarantee by yourself, regardless of what other people do, right? And that can be supported. So that basically, even without worry about what it is, basically means everything is possible, right? So basically, many people will consider this negative result, right? Because when your model say everything is possible, which means that your model is useless, right? So that's why in the recent 10 years, 20 years, game theory, replay game literature, they talk about the idea of monitoring, okay? By monitoring, it means that in a model, you can punish people because of you observe what have been done, right? If there's uncertainty there, you don't know. I just will quickly go over. So this is the model. Actually, it's a very famous model in the macro, but I think many of you don't study macro. But what it means is a very interesting model. Is you can consider a case where they are doing a I think Connaught game. Yes, they are doing a Bertrand competition. Okay, and you can easily see that Bertrand, right? It's easy. If everything observable, right, you would get you split the market, if the price is the same, right? If the price is different, then you lose the whole market, right? So you can easily detect someone is deviating from the collusion, right? So you lose some customer, then you know some guy is cheating, right? It's easy to detect, right? So you can imagine this is easy to sustain good outcome, right? Because someone, if deviate, then I will punish it to marginal cost forever, right? Which is that's only you need the outcome, right? In Bertrand competition, right? So how this model is fun is because this model actually, when it comes out in AER in the 80s, it basically comes with the result is interesting. So we consider the case where the economy can be good or bad. So the market demand can be QH or QL, okay? And this is random, okay? It's 1 minus WW. So just like the economy is good and bad, okay? The interesting part is, okay, you know the economy is good and bad at the beginning, okay? And in the funny part is, okay, in that case, right, every time two firms compete, at the beginning of period, you know is economy good or bad, right? Just change this, right? You can still observe other people's what they're doing. So turn out that it's very interesting result. This is the result that one of the equilibrium says the following, okay? It will be if, of course, you can imagine if they're patient enough, they're super patient, you can always sustain good outcome, which is they collude, right? Set the price to the highest possible, right? Price is 1, right? Set to the highest price you can do, right? And the last one is also very simple. If people are impatient, you go to marginal cost, right? Which you can't make any profit. So that one is, these two are pretty straightforward, okay? The middle one is basically what makes him get the AER. It's very interesting thing is, counterintuitively, you will see only if bad economy, you will have price 1, okay? In a good economy, the price is lower than 1, okay? Pretty surprising result because you expect, in general, in standard econ model, right? You would say good economy, higher price, bad economy, lower price, okay? But it's so that actually, if you consider collusion, that actually price become counter-cyclical. Of course, they will try to say this is mapping some macro stuff, but that's not our concern. But you may ask why, right? You may ask why is the case. So basically, this is what it is, right? It's like if this patient enough is 1, if not patient is here, right? And if economy is bad, it's here. If good economy is here, the price. Actually, when you get more patient, actually get closer and closer to 1. And so without going into detail, you can basically check what they are. But let me tell you the intuition, why we have this kind of crazy stuff, okay? The reason is that, okay, if, okay, we're in a low demand, right, economy is bad, right, and it's easy to collude because the stake or the future is much higher, right, because now if you defect, the gain is not a lot, right, because you only gain from the resection profit, right, the future has much larger, right. Let me repeat the statement. We're in recession, okay? The demand is low. The gain of cheating is just sharing the recession profit, right? The future is bright, right? So that's why in the recession, we can collaborate because the time is bad now, right? If we are cheating, we gain little, right? Compared to good time. So that is the idea, okay? That's the idea. So that explains why in the real world, they try to explain why you have a long period of high price and sometimes interrupted with very aggressive competition. That is what that paper is, but I don't think that would now people would care that much about this intuition, but the intuition suggests is in the bad time, actually people can collaborate, which is not surprising. If you see, I mean, a little bit elaboration would be imagined when earthquake, when crisis happen, actually people can collaborate easier, right, than other way around, right? If you look at in the case where I guess in the 1997, 1990s, right, when financial crisis happened in the Asia, right, you look at people, the news is South Korea people, every people sell their gold and give the money to government at that point, right? But you don't do it in a good time, right? In a bad time, actually people can collaborate, okay? And this suggests that somehow it's like bad time actually create collaboration, right? I think there's a famous quotation in the web. You will say, weak time create strong people, right? Strong people create good time. Good time create weak people. Weak people create good times. Somewhat like that, right? Somewhat like this cycle, but this is somewhat related to that, right? I guess, right? Because of the crisis, you know the future is bright. Of course, this model has limitation because of the fact that we know from macro or from our intuition, we know that thesis cannot be independent, right? This W, high or low demand, is related, but the main idea will be the same, right? Even the correlation, you can still say this kind of thing you can see, right? Bad time actually can collaborate, right? You see a lot of case in Chinese history, right? When the emperor who start his own dynasty, right? And they can live nicely when they're poor, but they cannot share their rich, right? 公患难易，共富贵难, right? That is what it means, right? It's easy to be fine if the situation is bad, but it's difficult to collaborate, right? Especially if they're not patient. Of course, if everyone's patient, no problem, right? Or everyone is impatient, they fight to death. But in the intermediate case, that is a little bit more complicated, okay? And that actually makes more fun, right? Because that means that when you look at with the game, right, you should look at intermediate range to be more fun, right? And from experiment, we know everyone is somewhat impatient, right? So that I think that would be a good thing. So lastly, I want to mention another model, okay, which also very famous. These two models actually, when you look at game theory textbook on the game, the game can be very thick textbook. But one of the also important model is this secret price cut model. Okay, basically same Bertrand model. Okay, but in this model, you can't really observe good or bad perfectly, right? That one is perfect. Okay, so it's not perfect, right? So you can only observe how much you sold, right? And you can also, the price recul can be due to the fact that the demand is bad, right? Can be due to the economy is bad, or it's because of the other guy cheating, right? So you can't distinguish whether you can earn that much of profit. It's because of the other guy cheating, or actually the economy is bad. Okay, you can't distinguish. So that is the main model of this, right? The same, right? Almost the same, right? Same probability, but this W here, right? But you just can't distinguish. So the model is like this, right? It's like you would have a demand and the profit. If you lower the other, same as the standard Bertrand, nothing new, right? The total demand is 2, right? And as I said, right, you don't know the other. The problem is in this type of model, you can't do Grimm trigger. You can't say, I cannot sell collusion price, I go to the Nash. The reason is there's always econ is bad, right? Then it means that as long as this econ is bad with positive probability, you run over the period, you can always go to Nash, right? You will never sustain collaboration, right? Because even though every one of you is very honest, we collude, but economics become bad, right? Then you go to Nash, then you forever Nash, right? Which means that we sell at a zero price, right? Say, suppose we collude at the price of 1, right? But econ is bad. Then you don't sell as much as we think. Then should we go to Nash? No, right? So that's why the Grimm trigger is not optimal, right? Because what does that mean? Okay, it means that there are many ways to do it. Okay, one way to do it is we call rely on a public signal. Okay, the way to do is actually what they do is, okay, if this is a signal, you can imagine the sky is blue. You collaborate, the sky is blue. If you don't collaborate, the sky is not so blue. Okay, there's something we observe. Okay, but what is it? Okay, the following. The way to do is slightly more is a little bit of a complex strategy. Okay, but the way to do is this. Okay, at the beginning we collaborate. Okay, that was what collusion. The game start. We collaborate. We collaborate when the game start. Okay, we collaborate if we have been collaborating, or we know I have earning a high profit, I continue. Okay, at the beginning, honest, no cheating. If we have been enjoying profit, no cheating at all. Okay, and the next two is a little bit more complicated. Okay, the first two is the same as what we call the Grimm trigger, right? Starting, cheating, right? Colluding, and have been colluding, continue collude. Okay, the next two is a little bit more complicated. Okay, the next thing is, okay, we will, okay, look at the sky. Okay, look at the sky. If the sky is blue, the sky is bright, we have good mood, continue to collude. Okay, even though last time is not. Why? We need to forgive. Okay, we need to forget. We need to have bad memory in order to sustain collaboration. Okay, let bygone be bygone. If the sky is blue, that's what it means. Okay, what it means is if yesterday is not have a good outcome. Okay, I don't know whether the guy is cheating or is the economy is bad. Okay, but we look at the sky. Okay, if the sky is bright, okay, we forget. Okay, that's actually no different from Asian world, right? In the Asian society, right? If someone commit a crime, we don't know it's true or not, we ask the God, right? Or he toss a coin, right? If he come out, the God said, no problem, no problem. The God said, punish him, right? So we look at this, looks crazy, right? But actually, it makes sense because if we don't know whether the guy is actually do the wrong thing or basically it's nothing related to him, right? We let the God or just a dice to decide whether we should punish him or not. Okay, so that's what it means. And 1.4 actually means the punishment has finite period, right? Grimm trigger is punished forever. Okay, in this model, you cannot punish forever. If you punish forever, then you always punish, right? So you have to somewhat come back. There's a finite period punishment. Cannot punish forever. Okay, so let me repeat, right? 1 and 2 is same, right? You collaborate for a long time, and you collaborate as long as you collaborate. And 3 would be you will still collaborate, okay? Even the past is wrong, but look at the sky. Look that both of us look at the same sky, okay? That means that we decide kind of together, the sky is blue, we forget, right? Implicitly, okay? We look at the sky, okay? And there's a finite period of punishment, right? Suppose he has been punished for long enough, then it's done. Okay? And the tool is very simple, right? If the previous 2.1 means if the previous period is a bad outcome, okay, and the sky is not bright, okay, we just punish this guy. We just punish, okay, and we punish for how long? For T period. That's it. Okay. So let us review this structure because you will see the same structure in this type of model. Imperfect monitoring will be okay. We continue to collude whenever we start, and whenever you've been colluding, why stop? Continue to collude. Okay? When things turn out badly, we don't know that it's wrong or not wrong. We look at the sky. The sky is blue, continue to do the right thing. Collude. If the sky is not blue, we just, I don't know, we don't care. We just go into the war. Okay? Kill each other for a while, okay? And kill enough time, then we come back. Okay? So that is what it is. Right? Is that clear? So that is what it means, but so that is what imperfect monitoring. So that is what the game I don't see, but that means that okay. If you look at the equilibrium, what it suggests is okay, even in the equilibrium, okay, even in this equilibrium, right? It means that even they collude, they will feature collusion for a while and fight for a while, and collusion for a while and fight for a while, right? Because you don't know what happened, right? By randomization in this along the equilibrium, right? So that means that even they colluding, they will fight for somehow. Price war doesn't mean they don't colluding. Price war is needed to sustain collaboration, right? So that's what it means. That means that there will be collusion and price war at the same time. Okay? They actually fit what we see in the classical wisdom in Chinese, right? We said when a couple, they fight, okay? They fight at the beginning of the bed and peace at the end of the bed, right? 长头打架有长尾和, right? That's what it means, right? It's just like they would fight, right? And somehow they done, right? And fighting is normal, right? Actually to sustain collaboration. Without fighting, there's no way to do it, right? And that is what it means, right? You just take time, right? Take time to you have to fight in order to sustain the peace. Okay. So okay. In this, it means actually one thing, right? It means that we need to burn some surplus. Okay. It means that there's no Pareto optimal outcome, right? Suppose we fight. Can we renegotiate again, right? If we can renegotiate again, that means that we cannot sustain collaboration, right? Do note that in this somehow, we need to make sure that if we are in the punishment, we still want to keep the punishment, right? So we have to commit to fight in some sense, right? We cannot say, here we just say, okay, let's peace, let's no fight. No, you have to fight. Okay, fighting is actually needed to sustain this. Otherwise, if you can always talk, there's no way to do it. Right? You have to figure out some way you can punish. Right? I think it's same as the marriage. Right? When the couple fights, right? The woman can go back to her home. Right? 回娘家, right? Can safely commit not to go back for a while. Right? If there's no way she can go, then there's no way you can collaborate, right? Because if she cannot go there for punish the guy, right, for a while, then you break down the marriage, right? So you can see there's something in the background here, right? You need some efficiency to sustain some good outcome, okay? So sometimes you see in the world, we see some inefficiency, and doesn't mean that actually inefficient. The inefficiency sometimes is needed to support efficiency, right? If there's no punishment happen, you always go to 0. Okay, you always try and go to 0 forever, right? So I hope I answered that. Some of you actually ask if this has been done so thoughtfully. What is doing recently in the literature here is there's a big literature talking about. Some of you would say, okay, this is crazy. Who is looking at the sky, right? I actually can tell you that there's a case in Cartel. Actually, people look at the sky. They look at the day of the week, who is going to be the leader of the market. Say if the moon is here, you are the one who do the job, and so on and so forth. I mean, there is things like this rotating, who is going to be the guy. But anyway, but probably you would still ask, I mean, in general, there's no sky to look at, right? And because how can you collaborate between China and a firm in China, a firm in the US, right? There's no sky to look at, right? And that's why they call private monitoring, right? There's a random device everyone can observe. And recent literature they talk about if there's no such thing, everyone look at his own stuff, can they do it? Okay, but it's way beyond what we're doing. But that's what recently they're doing. There's still breakthrough on that area. But of course, you can see this is an interesting thing because firms collusing, right? Because that is what you want to consider. And for environmental, right, that is also very important, right? How you can sustain. Okay, so let me go to the thing of the topic today. Okay. So don't worry, today's is we're not very ambitious because the idea is very simple, but just the math is a little bit more complicated. Okay, but the idea is super simple because we go back to the static game. Okay, and with incomplete information. Okay, so let's get started. Okay. So we learned so far, right? Everything is complete information, right? And for those people who from finance, right, and accounting or marketing, they would just say no way, right? A lot of the things happen because of incomplete information, right? And because of information asymmetry, right? Some people would have much more information than others, and what we're doing is rubbish, right? There's a lot of information actually drive a lot of stuff. Right? Later in the Wednesday, we talk about contract theory or adverse selection. You will see information is one of the driven a lot of stuff, right? And how do we solve this problem? I mean, it takes quite a while. Hassani, they come up with the idea we call, instead of talking about incomplete information, instead of talking about I don't know what is your payoff or what's the game. Right, because in the real world, right, suppose I compete with you or in a market, right, I actually don't know my competitor's cost, right? I don't know his payoff. I don't know what he can do, right? How can we find equilibrium? What's the game, right? Because for next equilibrium, we need to know with the other guy, what are they doing, right? Otherwise, how can we find? So what he proposes, instead of imperfect, so incomplete, they call imperfect information. Instead of saying, I don't know what is the cost, I would say your cost may be $1 with probably 0.5, $2 probably 0.2, $3 probably 0.3, so on and so forth, right? We assign probability over what you might be. Instead of saying, I don't know. If I don't know, I cannot proceed, right? So we have to figure out some way to proceed. I make some conjecture what you might be and put probability over it. Of course, that is kind of, you make some assumption there, but that is a convenient assumption that we can proceed, okay? And we know, right, from probability, right, we can always start with prior, we can start with uniform, we can make some guess and try to make some judgment, okay? And that means that we need to decide what is the types of players. and the type is chosen by nature. Okay, and every players, depending on type, have different actions or payoff. Okay, and do note that it's the nature who decide. Okay, so that actually means that this is no different from we studied last class, right? It's just like the God or the nature decide which type you are, and you play the game, right? It's the standard subgame perfect idea. Okay, so actually it's a subgame perfect idea, but of course we will give another name because of later you will see why. But there is no different from subgame perfection, right? But nature is not strategic. Okay, nature decide which type you are. You are high cost or low cost. Okay, but you will see a little bit more tricky. Okay, so you will use the type, as I said, to define your private information, right? The type is whether you're a high cost producer or low cost producer, right? And different costs would means you may have different payoff, you may have different action, right? And your type also affect my payoff and my action. Okay, and also because of I know my cost. Okay, I know myself, right? And depending whether I'm high or low, may affect my judgment about your high or low. There may be some externality there, right? Because our costs may be correlated. Okay, so that's a little bit more complicated. Don't worry. This slide is a little bit, you can read it later, but I already mentioned the main important thing. So the main thing is like this, okay? That is called, important assumption is called common belief, okay, or common prior, which means that the type, okay, everyone would, before this is the nature, actually draw from this, the joint distribution of for each type of each agent, okay? T1 will be, suppose I'm the guy number 1, I can have high cost or low cost, okay? And you also can have high cost, low cost. You are player 2, just on the 2 player, high cost, low cost, right? So the probability, right? There are actually 4 combinations, right? I'm high or low, you're high and low, 4 combinations, right? And which 4 combination comes out, right? We know it from the nature before play the game. We agree that the nature will be drawing from these 4 outcomes, okay? But the conditional probability, right? Given that I am a high, you are low or high, we come on the Bayes rule, right? We follow the standard Bayes rule. That's why we call this type is called the Bayes-Nash equilibrium. Is the nature draw 4 different combinations. Okay, we agree on the nature, and once I draw this, I would derive from the nature how I think what you are. Suppose I'm high type, I'm high cost, I will think you are low or high, depend on this P. If I'm low, I will also form this belief. Okay, so how I think whether you're high or low, right, depend on this P. Okay, it can be different depend on high or low. Okay, so and this is assumption. Okay, and let's see the example, and then you will see what it means. Okay, so let me quickly look at this model quickly. So don't worry, it's very simple. So we have a set of agent, right? Set of strategy and payoff, right? This NSU is same as static game. Okay, what is new here? Okay, let's look at what's new here. First one is a type. Okay, the type is a new thing. Type, maybe remember, is whether you're high cost or low cost. Okay, that means that your payoff will not only depend on action chosen by all other firm, also depend on type, right? Because it affects my cost structure, right? It also depends on other cost structure as well, can be potentially. So the payoff not only depends on what action you take, but also depend on who you are and who the other peoples are. So that's only the first thing, right? The type. Okay. The second one is you have to tell me belief, P, right? You have to tell me if I'm a high type, Suppose I have high cost. How I think you are high or low cost. Okay? And I'll tell you that if you are high cost, how you think I'm high or low. If you're low cost, I'm low or high. Okay? And of course, this comes from that one. Okay? This comes from the base rule. Okay? But don't worry, you never work in the base rule. Okay? Because there always you can come up with the prior anyway. You just have to tell me what is your belief and what's my belief, right? And that's it. Okay? And of course, that has to be consistent, come from the base rule, but as long as you, in your application, you never have to worry about the original P, right? You just need to tell what is probability that I'm high or low, what's high and low, then you're usually done, okay? You can always come up with, usually in application, you always, almost always, you come up with objective probability for everyone, right? You say probability that firm 1 has high or low with this probability, firm 2 has this probability, and that's it. Usually you would not go complicated and say, if I'm high cost, I think he's more likely to be high cost. Correlation between between outcome is very, very rarely seen as application. Okay? But it can be done, right? Maybe I'm high cost, I likely to think you're high cost. I'm low cost, I think you also may like low cost because our cost may be correlated, right? So let me go to one example before we break because I think that would be very good to have a break here after the example. So a little bit longer today. So the only complication in this is what we call Bayesian-Nash equilibrium. Okay? But indeed, this is just subgame perfect. Why? Let me draw a diagram here. Okay? The diagram is like this, right? So basically, it's a nature. Okay? Nature move first. Okay? Make it simple. Okay? Nature move first. Okay? And make the game like this. Okay? Suppose the game is like we are playing Connaught. Okay? And later you see this example I do is only I have uncertainty. Okay? You know your cost is $1. Okay? You don't know whether my cost is either $2 or $1. Nature decide. Half likely I am $2, half likely I'm $1. Okay? So like this. Half probability, my cost is $1. And half likely my cost is $2. You always have $1. Right? And after that, we are playing the Connaught game, right? And I choose my quantity here, right? And then you also choose your quantity here, right? You're player number 2 here. And same for this one, right? The way I draw this is a standard way to draw continuous strategy. Okay? Instead of writing the tree, you would draw a curve to tell me that I can choose anything from 0 to infinity or 0 to some number. So instead of drawing all the line, right? Because continuous you can't draw, so that's why I draw like this, right? I choose my quantity, you choose the quantity, and you choose the quantity, I choose my quantity, right? So you look at that in this model, the strategy for a player is very complicated. Okay? For you, you don't have uncertainty. You only have one type. Your cost is always 1, right? So for you, your strategy is very simple. You just choose what you produce. Okay? But for me, it's rather complicated, right? Because I have to say, at the beginning of the game, I have to tell if nature told me I'm low cost, what to do here, right? If I am high cost, what to do here. So my strategy is to tell me for each cost structure what I would do. Okay? Which means that I have a game 2, game 3 here. Okay? So the Bayesian-Nash equilibrium simply means a subgame perfect if you draw this game. You draw this tree, right? So basically just like, okay, every type, I tell me the action. Okay, what's the action I'm taking? And if A is a Bayesian-Nash equilibrium, right? Which means that everyone, for me, right, this action is maximizing my expected payoff, right? Because as I make the decision, right, I don't know where I am, right? There's some probability I'm left or I'm right, right? I am trying to see if here or here, which strategy will maximize my payoff, okay? As long as it maximizes my Can you ask where did I stop?
That's about 2 minutes.
Okay. Sorry, I just go back 1 or 2 minutes ago quickly. So let me go back to 1 or 2 minutes ago. So in this game, okay, is I'm firm 2, you're firm 1. You know your cost is always C, okay, and my cost can be high or low. Okay, everybody agree I will have high cost with probably theta, low cost minus theta. So you can imagine why this thing happened is an entry game, right? You are an incumbent, everybody know your cost because you're a public company, I know your cost. And I'm a new guy, I have a new technology which may turn out to be very good, okay? Low cost, minus theta. Maybe as it's not very so good, it's very high, okay? So the question is, everybody agree this uncertain, okay, there's no conflict about the probability. Okay, that's a big assumption here, but we have to make some assumption to proceed, right? If everybody disagree, how can we proceed? But that is the current we have right now. And do look at the main difference of this game is, as firm 2, you have to tell me if you are high cost, what to do. If you are low cost, what to do. Okay, so that is main difference between. So here you can see if high cost, this is your profit function. If low cost, this is profit function. So it means that you have a best response, okay, depend on your type, depend on your cost structure. So there are two best response. But do look that there's no mixed strategy here. Everything is pure strategy. You're just saying that if you are low cost, this is how you behave. If high cost, this is how you behave. Okay? So that means that there's only still a pure strategy. Okay? But the difficulties lies on firm 1. Okay? Because the firm 1 don't know which thing will happen. Okay? So he is a expected utility maximizer. So he would take these two things into account on average. So you can see what he will do is he maximize expected profit, expected utility, right? So it means that in theta time, he actually meet high cost. In 1 minus theta, he will be looking at the low cost, right? He will weigh into this probability and do the best thing, right? He already know firm 2, right? He will behave differently, depend on the situation, okay? But he only can give one response, okay? And that means that he will actually do something intermediate. Actually, you see, all right? Strike the balance. I know if you high, you do this. I know low, you do this, okay? And I know that theta of time, I'm facing a high cost of you, and 1 minus theta, I'm facing a low cost of you, okay? So I try to strike the balance. So they will maximize according to this, right? So what I do is I plug in the best response, right? So this is my best response, right? My best response, okay, depends on, my Nash equilibrium depends on high type of firm 2 and low type of firm 2, okay? So that is the thing, okay? And that's best response, okay? Now, what is the outcome here? Okay, what is the solution here, right? You just plug everything in, right? Because best response, right? You just plug in here. So that's slightly different is, it seems to be, okay, it become a 3-person game, right? It's just like you have a high type firm 2, low type firm 2, and firm 1, right? Basically, just, you can imagine it's similar to that, right? Similar to a 3-player game, okay? Player 1, who don't know, we just play against 2 guys, and firm 2 high type and firm 2 low type, okay? Just basically solving this game. And so that's why you see there's a free equation, right? Because this is similar to solving a 3-person game, right? Just like firm 1 is solving facing the 2, firm 2 would actually know who he is, so basically just as simple. You just solve these 3 equations simultaneously, right? So basically just 3-person game, right? And we know how to solve it, right? Just solve it. And I'm not going to bother you with the math. I want to let you see the outcome here. So basically nothing deep here, right? So solving this out. And this is the graph. Looks crazy graph. Don't worry, I'll go slowly, then you'll know what's going on, okay? So let's look at the blue dashed line. The blue dashed line is the line that actually firm 1's response, right? Firm 1 response, okay? And this is same as the case where without incomplete formation, okay? Let's go back to the previous chapter, then you will see why I said there's nothing new here. Go back to here. Remember this game? Same blue? This game is, we have here, right? Is this game. symmetric linear equilibrium. There's no uncertainty, right? This is this line. Okay? So the first is, this is firm one best response, right? Without knowing whatever, right? If you told me what Q2 produced, this is what your best response, right? Because we forget about uncertainty, right? What he doing depends on what Q2 do, right? This is the best response, okay? And look at the red one, okay? The red one is nothing new, but same as what we have seen before, right? Because like this one. The only difference is he have two different C. That means who have a two parallel line here. So the red is the two parallel line here, right? So there's nothing new here, right? So that means that the blue and the red, you shouldn't be very surprised, right? Because the same as O thing, right? The only thing is firm 2 know his cost, right? That means that this best response will be parallel, depending on the C, right? Same thing here, right? There's nothing new in this graph, okay? The only fun thing is, okay, look at this. Suppose I know for sure the firm has a high cost. Then this is the net equilibrium, right? If I know for sure it's low cost, this will be less. The green one will be less equilibrium, right? Is that clear? So, okay. Okay, how can I make the series work? But anyway, so the blue one will be the one that if we know for sure he's a high cost, right? The green one will be net equilibrium for sure if I know he's a low cost, okay? And turn out in this particular case, if I assign theta as high cost, 1 minus theta will be low cost. Turn out the net equilibrium is just in the middle. Theta, high cost, the low cost, okay? And of course, this is, in general is wrong, but in this particular case it's true, okay? In this particular case, it's basically the outcome is just theta time high cost, theta 1 minus theta low cost is just average outcome, okay? And of course, in general, it's wrong. It's not exactly in the middle. Because the way that your best response is linear, okay? It's linear in this way, so everything become linearized. But in general, it's not in the middle. So don't let this example mislead you to this, but in this simple case turn out to be, okay, because you are this, right? Firm 1 actually thinking, theta is here, theta I'm here, okay? So how can I respond to that, right? Turn out to be in the middle actually maximize, right? But you can imagine sometime maybe here or here, really not be in the center. But he still should along this line, right? In general, right? In general, but that would be because it's linear in the payoff, right? If this is like a curve, then will be may not even along this line, right? Can be anywhere. But I hope that try to explain what base Nash equilibrium here is, right? Because it's just very simple. You just imagine that people have type become one player, right? And when people do maximization, you just maximize over what can be for the others. Okay? So basically what it's doing is every type, right, can be considered as own payer, right? But when each player evaluate payoff, you will group the other player together into a side probability, right? You'll be thinking, I have some probability I meet this guy, I met that guy, okay? So basically just like multiple player game, but when people calculate payoff, you calculate expected probability meeting those, and everything will be the same. Okay, so that's, as I said, there's nothing new here in terms of calculation, but the conceptually, hopefully understand, right, is to remember is every single type, okay, you have to assign a strategy, okay, and that is different because that is actually following from this, right? You have a nature, right? You go down, right? Okay, and that's end our and this part of the class, and this up to here, this is exam over up here. After that, we'll talk about other things. I think also important. Let's have a break of 15 minutes, and then we come back, and yeah, I guess that should be okay. And yeah, let's have a break of 15 minutes.
你有在做一个人本上是这个，都是从训练里面有机会，而且然后。可以上层，基本上快给你们上。这几个最高满3所以就是大家那个对就这样子。然后我试图搞懂那个促成这个我就是我做完了，我没有做完，挺搞笑的。先是我看了一下，我说我不是我又考在了第6题，另外一道题，然后正好就是应该是他在教第2完全，就是那个应该是敲灭了，真的我搞不懂，而且我觉得不是我一时半会儿不是我一时半会儿搞懂，所以我有点放弃了。我有点想把记性多一点，然后我真的把它讲出来。为什么要讲？对啊，对，就是我直接忽略了，就我直接就是算不清楚。就是我没懂这个 RC 是谁干的？对，就 RC 就是它是这个我能理解它的是对这个东西，我想这个 ET 但是 ET 是不是 rate 就是我没搞懂为啥？这个它是啥而且它这个时候面还有人这样，它这个没有说对，绝对有。你往后看，还有一个就是第5没有预算，这个位置当时是要换吗？所以我没搞懂它在这儿。我都没搞懂，直接就是 rap 我就拿一个小这个，然后别的图不同。因为你需要给他们应该在不浪费，我现在就我昨天，不是我今天看完了之后，我感觉又不懂了，因为什么他们讲的没有，就是因为他是选这一个点，对，还有就是接的是那个就是 T+P 这段，然后就是开始讲然后这个地方是在理解它第一是理解对，因为它是基础。
那是对的。因为你穷的时候才觉得给你1块钱很开心的，有钱的时候给你10块开心。
反着想。也不算反着想，因为他这次一直在
因为你们是吗？最接近的。
对，是。
不用画了吧？
不用画，不用画。
你说，我们说 research 连起来有框点。
就感觉一开始一直在，我一直想的是，他经常有说路逼的是啥？
为什么？ Oh, let's resume. Sorry, for a little bit delay. I guess it's over, so that's why I have to do this. So, as I said, everything that we need to cover for our exam already over, so we can sit back and relax and enjoy. Hopefully, hopefully you still listen. But anyway, this class is a record, so if you feel anything tired, you need to come urgent to do, feel free to do it. But it's PhD, right? So I hope you still pay attention. I guess the following talk about auction for the remaining of this today. So I think it's still very useful. And auction is often used in finance. And auction is, we don't talk, at least I don't talk about mechanism design right now, but auction is some what we call precursor of mechanism design. So auction, you can think of this as generalize it, become a mechanism design. And mechanism design is the idea where you are a designer, okay? You face many agents who may strategic do things, but you try to implement an allocation, okay, by making them to do what you want to do. And it's very often used in practice, right? Anyway, but let's talk about auction, okay? So auction by itself is a very, very large topic. So you can study for a whole semester for auction in US. So that's a second year course for auction. So you can imagine we only have half a class. So the thing we can cover is very limited, but I hope this would give you a glimpse of what it's going to do. And auction is still often studied, especially in engineering, in or optimization problem, because of in the model where we have only one item being auctioned, things can be solved nicely. But when more than one object, then things become very ugly. Okay, so that's why most of the result, what we know is still one dimension or one single object. More than that, become more complicated. The reason is being that when object is complement or substitute, how you set up the option format will be very complicated. Okay, so that's called combinatorial auctions. How to design them is become an engineering problem. So it just go away from economics. But of course, if you look at history, who first studied the auction is by engineer. Okay, and go back to economists and now go back to engineer. Because now it becomes so complicated right now. But still economics can bring us very far. Okay, so now let's get started with auction. And once we do auction, we'll talk about double auction at the end. So double auction means that actually is what constitutes a market. What double auction means that I'm a buyer or seller, right? Buyer would tell how much I want to buy. Seller would say how much I want to sell, right? So they try to interact in the market. So they both simultaneously give prices. So basically, double auction is what happened actually in the stock market, right? Stock market, you submit a bid and ask, right? And they will do that, right? So basically it's just like a stock market. So basically why the finance literature, they often look at this, okay? And but let's go to the very simple one, okay? So why we look at auction, okay? Auction is used when actually I don't know the demand. Right, suppose that look at the eBay, right, the world largest auction house, I would say, right? And why you would have to sell things in eBay, not in Amazon, right? Or Alibaba or Tmall or whatever, right? Because if you sell those places, you have to say the price, right? But when you auction, you actually don't know the price yet, right? You don't know the market, so you cannot set a fixed price, right? Setting a fixed price, you actually losing, right? Because you actually don't know, you're not selling the highest price, right? So in order to maximize your revenue, right, you do auction, right? In that sense, auction is what we call a price discovery tool, right? Actually, what the financial market is, right? Financial market is basically double auction and to discover the price, right? That's the market, the auction was used, okay? So when there's no market, right, and the item is very rare, right? That's why antique is sold in the auction, right? Land is sold in auction, right? Because land is particular land, a plot of land by the government is where you need, right? So it has to be sold by government, right? And that's the idea, okay? We don't know, but we want to maximize our profit, so that's why we do auction. Okay? And you will imagine what is so special about auction is the fact that in auction, okay, there's a specified rule, is well specified. In what condition this item will be sold at what price. Okay, so that means that there's commitment power there, and the price discovery is explicit rule. Okay. That's different from the case where you go to supermarket, go there, you know what price to be got, okay? And that is sometimes if you go to Israel, probably not the right time to do it now, but actually when you go there, I luckily go there once. It's very fun. So it's an old market there. You go to every single store, there's no price. Okay, they put there in the store. I'll show you the picture. It's very fun. I go there when I do my Ph.D. There's a so look like this kind of store. Okay, you go there. There are many items there. Okay, and there's nothing written the price there. Okay, you have go there. How much is this? And how much is that? Okay, you ask him this in the morning, can be different in the afternoon, and they usually give you a super high price. Okay, so suppose try to sell you this coffee. Okay, the market price I think is like $20, $6.60, right? They will say 100. Then you have to tell 10. Okay, they say no. They say 50. I say 20. Then okay, so okay, and something like that. Okay, so you have to go back and forth, and they're very good at that. They've been doing this for thousands of years. So there's no single price that they never try to tell explicitly. At least when you go to there again, if you have luck to go there, then you will have fun of that. There's no price, right? Even this is for tourists. No price. And other place in the world, right? You would know the price, although the price is crazy, but you know the price you're paying. But here you have to talk. Okay? Because this is different from many cases, right? A lot of time you go to a tourist place, they say no bargain. And you go to Jerusalem, it's bargain only, right? So that is a little bit funny. But they're still there, okay? So what is auction? Auction, the word actually means augment, or means increase, okay? So the oldest history, auction, in the written history, turned out to be in the Babylon time, where the father would bring their daughter to a city center. They sold their daughter for marriage. Okay, from positive price very high, keep go down, and to negative price. So if no one buy the daughter, they will say you get it for paying you this to get rid of the daughter. Okay, so that is what happened. Okay. And another very famous book, another very famous auction in the history is Roman Empire in 200 AD, okay, around. So the bodyguard of the emperor actually killed the emperor. So they come together and kill the emperor, and they kill the emperor. Then they can't become emperor, right? Because it's just a guard. So how they do is like he asks everyone, okay, who promised to give them the most money will become the new emperor. Okay? And of course, the one who promised to pay cannot pay. Right? They promised this guy a lot of money. But of course, the emperor, the new emperor cannot pay. So they kill this guy killed the emperor again. Okay? And of course, the empire become chaos, and someone come in and kill all this guard anyway. But that means that there's one thing comes out is from this is called the winner's curse. Means that actually the one who win turned to be overpaid the thing, and so I mean that's what happened. And a lot of times it happens like the bidding of oil, right? The oil, there's an oil drill. Right? You don't know how much oil there, right? And usually the one who win is actually who overestimate the bid, and that means that overbidding happened. So whether overbid is the feature of the model we will see, but that is one of the main theory that people study in auction is whether overbidding or winner curse would exist. And so that is one thing. Okay? And there are many modern auctions, right? For those who like Japan, right, would love to see the fish auction, right? Every I mean, I should show you the picture, right? Because it's interesting. I never have chance to go there, but we see a lot of things in 足地这个足地市场那个 auction. So like this, okay? And every morning, right? They got all the very big tuna or big fish in the very early in the morning. And because each fish is different, right? So they have the auction because each day they do sashimi, right? Go get there, and they will do it very early in the morning. So I'm not early enough to do it because it's very early, like 4 or 5. If you go there after 5:30, there's nothing. So my friend also wanted to do it, but it's too late. Go there by 6 is too late. But it's have to go early. But you can also see the video YouTube a lot. So you can click later. You can go home and see this. But it's still there. It's still auction this out. So it's very fun to see those kind of auction. Flowers in Netherlands are slightly different. It's called Dutch auction. Usually the auction is like low price to high. This is slightly different from high to low. Okay. Later you will see in theory, they're no different from up and down and down and up. They should be the same. But you look at behavior, slightly different. But we will not. If you're from finance, you know government bond in US is sold by auction, right? And in Singapore, or I think also in Shanghai, is it Shanghai? You bid the car license, right? So this is the highest price you get it, okay? And the spectrum, if you are, maybe you guys are too young, but in 10 years ago, 3G is a big thing. Before it's a Nokia 2G thing, right? And we then come to the age of 3G. 2G only SMS. 3G you can have internet and things. And at that time, 3G become a very big thing. And they sell the 3G license, become a so huge stuff. Huge, a lot of billions of dollars. And actually where is the highest time of economists is during the sale of the 3G spectrum. Because economists involved in this, and this is side of one of the biggest contributions of economists, is designing this kind of auction to make revenue for the government, selling multiple $billion and how to design it. And IPO, everyone knows IPO is a big thing. Of course, now IPO in Hong Kong become nothing, but in the old days, it's still very big, right? eBay, I have mentioned, right? Or auction. And because IPO, right? Because I don't know the new company, how much it's worth, right? So it relies on auction. Okay. So in the literature, there's 4 common way to do auction. Actually, this 2 is rather standard, right? It's called English or Dutch auction. English auction is you go to a venue, right? There's a guy who say keep going the price, and until only one left, that will be the price being sold, right? Dutch auctions is reverse. You start from the very top, very high price, keep going down, and once say I like it, then it will be you. Okay? So these are English auction and Dutch auction. Okay? And this is what happened in the real world, right? In the Hong Kong government, they sold in the English auction the land, right? And also in a lot of antique, right? It's sold in the English auction as well. Okay? And then other common way is called the seal bid auction. That also happen these days right now. In Hong Kong recently, you know, I mean, when I want the MRT, right? This subway company try to sell the land, they use the seal bid auction. So what it is seal bid means you write your bid, put in an envelope and seal it. That's what the seal bid. The bid is your money. You seal it and put in the box. Okay. When the time is done, deadline is passed. Open all the bid, and the one who go to the highest price. Okay. And if you only pay the highest price, it's called the first price auction. If you only pay the second highest price, it's called the second price auction. Okay. And the first price CP auction is very common, right? I think that is most common thing you observe, right? And the second highest also very common, actually turned out to be people use it when in the old days they sell the stamps. So in the old days, people sell the stamps before 1950s. Someone have a rare stamp. I want to sell it to people, and people submit a bid, and you pay the second highest. Okay, and you probably would think these two is different. And one of the main results shows actually 4 of them are the same. Okay, that's one important result. We call the revenue equivalence result. Is if you are the seller, they're no different in terms of expected revenue, which method you're using. Okay, you don't care about first price, second price, ascending or descending. So this is the first result. Actually, I think proved by I think Meyerson. He proved for this. I think Meyerson or before it for the same. Okay, but there are difference still the 4, right? Otherwise, we see only one comes out, right? And later we'll talk about today is this is much more straightforward than the first price. Why? We will show second price auction. What you're going to do is very simple. Is you just submit a bid that what you think it's worth. You don't need to strategic. You don't need to care about what other thing. You think that land worth 1 million, you just say 1 million. Because you are not paying 1 million. Okay? You're paying, if you win, you're only paying the second highest. Okay? So we just need to put it, how much worth it to you, then you're done. We'll prove this point. So the important point here is, in the second price, one of the equilibrium or is you just bid, you don't need to strategic. You just do what I want to do, then you're done. Right? In the first price auction, you may need to think what other people would bid. Right? And at the end of the day, what you're going to bid is just marginal cost and marginal revenue idea. Right? You just to be indifferent between increase your bid or lower your bid. Later you will see. But that would be what you do. But the thing is, you have to ask your buyer to calculate stuff, right? That in behavioral sense can be more difficult, right? It might work in your favor or may work against you. But if you make it straightforward, this is more straightforward, right? That's why I think eBay or whatever they use the second price, if I remember correctly, right? And the second price will be same as the English auction, right? Because you keep putting the price, you're the last one, you're paying the second highest, right? And the Dutch auction, we same as this guy. Sorry, the first price auction same as Dutch auction. So the first one who will say yes, the same thing, because you're paying what we're paying what you react, right? And probably in the recent literature, that is very recent, fairly recent, and people point out that ascending auction, this English auction, is better than the seal bid auction. Okay? And I don't go to the detail, it's very technical, but they will say this English auction is even more straightforward than the second price seal bid auction. They call this is obviously strategy proof. So it's so obvious that you know it's going to be by so simple, you should just continue to remain in the auction. As long as the price now you're willing to pay, there's some surplus to it. So the price is lower than what you think it's worth, you still be there. You still could keep bidding. Okay? And then that means that it just means that the recent literature tells you should do English auction whenever possible. Okay, that is straightforward. You do the best thing. Okay, so that's why you will see English auction is the thing we see most often, right? Because in theory we can support it. But that is only happened in last 5 years development of the theory. So if you want to go to the frontier, that's what you're going to do. Okay? So, but I'm not going to talk about the frontier. So what about today is not going to talk about these two, but about only these two. Okay? Because talk about these two require you to talk about dynamics. Right? It's not about this class. Right? Because this is the game will proceed according to the current price. You have to decide whether to kick in or out, right? It's a dynamic game of incomplete information. Okay? But this one, we can talk about today. Because everyone, you just know your price, you submit your bid. Right? And you submit once, and you don't do anything further. So it's a Bayesian-Nash equilibrium. Okay? We can talk about this after that later, but this is not about this class. It's a dynamic game of incomplete information. Okay? But this is a static game of incomplete information. Okay? So we can do it how to do it. Okay, we can show how to do it. So I've already said there's an equivalent there. This first price still bid same as open Dutch auction. Okay? And the second price still bid is same as the English auction. Okay? So I'm not going to go to technical detail, but that is what people will be talking about. Okay? So now we put in a game. Okay? It's a static game of incomplete information. Okay? So auction is very simple. I have an auctioneer and bidders. The auctioneer actually is kind of not a strategy, not strategic. Okay? He just commit to a auction and then that's done. So you can auctioneer is not a player. Okay? He designed a game, but he's not a player. Okay? The only player is buyers. Okay? And the strategy is the bidder how much to bid, but auctioneer decide the format. But of course, he designed a game already. They play, right? So basically, he just like the sub-game perfect idea, right? He designed a game first and then he play. But you can imagine that the auctioneer is not going to bid anyway, right? The auctioneer is just there. Okay? And the payoff, of course, depend on the auction style and how they bid. Okay? And let's go to the formal model to make it easier. Okay? And before we do it, as I said, auction textbook is very thick. Okay? So there are many things you can do. Okay? And following the classical development literature, we focus on private value. Okay? Private value means how much I value the product, the good, between bidder are independent. I think this coffee worth $100. Doesn't tell you anything about yours. Okay? And the next one is another extreme, is all are really the same. Okay? But everyone got a piece of it. Okay? Means that look at the oil. Okay? At the end, they're the same. Okay? Maybe you look at part of it, I look at part of it, everyone look at part of it. The ultimate value depends on the joint estimate of that, right? So you can imagine the following, okay? Is I have a big object, okay? You only look at part of it, I only part of it, right? The true value depends on average of because I look at part A, look at part B, right? And very often this is what the oil auction they talk about that. Okay? And the other one is the most general model. Okay, it's called interdependent value. Okay, it's combined these two, right? It's my value is my value, but my value, if I'm value high, your value is also high, right? You can imagine that it's like the stock market, right? I think the IPO, right? I think the stock is going to be high value because I think the company is good. Okay, but also affect your valuation, right? Because when this is good, I think it's good. Actually, you also think it's good. Okay, but our model focuses on private value. Okay, and if you want to do, then you have to read the textbook, right? You say very, very deep subject, so I'm not going to continue. So I focus on very simple case. The auctioneer have only one object to sell, very simple model, and for him, the object has no use. Okay, and if he sell it, he got the price P, his happy is P. If they don't do it, it's no use 0. Okay? And we also assume various assumption there are only M bidders, and N is fixed, known in advance. Okay? Everything is making very simple. And everyone have different valuation. Okay? More than 0. And also very simple. If he got the object, he paid the price P, will be BI minus P. You don't get it 0. So we have a lot of assumption here, you can see. But even with this, you will see model is very complicated still. So that's why you can see why we make so much assumption. There's a space here, okay? So very simple. Sometimes this refers to quasi-linear utility, linear in money. But anyway, it's not important. So what is the problem of this? Okay, we want to see one thing. Okay, first is as an auction. Okay, as a planner or economics approach, we want to ask efficient allocation. Right? We want the object to be sold to the bidder who value most, regardless of what they're bidding. Right? We want to sell it to the one who value most. Right? Why? Because this is stable. Right? If it's not the case, then he can re-auction again. Right? So we really want it to happen. Right? The second is as a business school Ph.D. student, many of you are, right? And you care about how to maximize the profit, right? Because I want to choose an auction such that will maximize, right? And one thing I didn't talk in this class is optimal way to maximize profit. Okay, you have to set reservation price. Okay, which means that you can't always sold the object. Okay, the idea is very simple. Don't worry, I'll explain without going to proof. The idea is very simple. Remember monopoly. How monopoly maximize profit is to restrict output. Right? You don't sell as much as the private competition will do. Right? You don't always sell. Right? You just reduce the quantity such to boost up the price. Okay? Same as here. An auctioneer facing a group of agents, right? And I don't know how much you bid, right? But I would say, as long as I make it say I don't always allocate the object. Okay, I make it if too low, then I don't sell it. Okay, then I will able to maximize profit. Okay, need not always sell the profit. But anyway, this will be too advanced to talk about now. Okay, but I will focus on simplest case. Okay, so the model is very simple. If I want to do the auction, okay, if I want to sell it to I know who the value there is, I can just set the price, okay, equal to the highest bidder, right? And then I'm done, right? Now, if I don't know it, how can I do it? Remember auction, I have to tell how I allocate, what's the payment rule, right? Because everyone will tell me how much they want the object, okay? I will tell how to allocate. So, as I said, it's a mechanism design problem in general, okay? In the case that you have to specify two things, that is what mechanism design said, is you have to tell how the allocation at the end, okay? In this case, who get the good, okay? And here do note that we need not be deterministic. I can roll a die, okay? I can say, depends on how much you bid, this is the die I'm rolling, okay? Need not be, can be probabilistic. Okay? But in our model, we just deterministic, okay? It can be rolling because everyone have the same price, then I equally divide among the two. So I allow that happen. Okay, but anyway, doesn't really matter because our model turned out to be the valuation is a monotonic function of what you bid, so no one will have the same bid anyway. Okay, but payment rule will tell you that who is going to get it and who will pay what, right? And you may still need to pay even you don't get the object, right? In general, but in auction you don't, right? You just pay when you need to pay. You do get object, right? But in general, it can be we may be paying even though if you don't. Okay. So we'll model the base end game, where belief, the type is how much you value the object, belief is how you think about the valuation, right? So we'll focus on what we call the simplest setup. It's called independent private value, which means that we are going to thinking how much I value the object is dependent on use private value, and everyone only know their own value. Okay, I only know it's worth $10 to me. That $10 doesn't tell you whether you value more or less. Okay, so that is the simplest you can think. It's an antique problem. And we focus on the case is symmetric. So everyone the same, okay? And everyone value from 0 to 1, okay? The simplest you can go, okay? So now we actually talk about this and then we have a short break, okay? So we are talking about bidding strategy. It's very simple. Remember, is in auction you just bid, you just give a number, right? And your valuation from 0 to 1, right? You can bid is anything from 0 to 1, right? And it depends on, remember, baseness equilibrium depends on what your type is. So you have to, the strategy is very complicated. Is if you think the object worth $1, what you bid? If you think it's 50 cents, how much you bid? If you think it's 10 cents, how much you bid? Okay. For every possible valuation, you have to tell what number to bid. So it's a function. So your strategy is a function. For every possible realization you get, how much you bid. Okay? So you can see the auction is very complicated, right? You have to envision yourself. If I value this object at this price, at this value, how much I bid. Okay? Do it for every possible realization. Okay? So let me define this with break. This is called, if I bid what I value, it's called super bidding. If I bid more than my value, it's overbidding. If I bid below it, it's underbidding. So let's look at the graph. Okay. This is your valuation. Okay. This is I bid. So a strategy simply means a curve. It's not continuous, but there's a curve, right? For every valuation, I give the value. Okay? If I am not strategic, I'm truthful, which actually I said I will do in second price auction. Later you see I bid the 45-degree line. Okay? Yeah, that's what you do in second price auction. Okay? And the first price auction, okay? What you do is you will never do overbidding. Right? Because you are paying what you are going to bid, right? In the first price auction, you always bid shading. You always bid below the 45 because you have to pay. If you win, you have to pay what you have to oppose, right? First price auction say I'm bid $10. You have to pay $10, right? That means that if you value the object $10, you get 0 surplus, right? You must bid less than $10 or equal to $10, right? Suppose this coffee, okay? To you is you value at $10, okay? How much you should bid? Will you bid $12? No. If you win, you lose $2, right? You at most bid 10, and in general you bid less than 10. Okay? So that's why you can see later you see the equivalence of the first price and second price. It's because of in the first price, although you bid $10, but you're not paying $10, right? So that's why you actually get something below. And in the first price, you will never bid 10. You bid lower than that until it will be this same for the seller. Okay, there's no difference. Okay? And of course, you never overbid in the second price auction. Okay, the question is when you overbid, right? You will not do it in the first price. You will not do it in the second price. But if you ask third price or fourth price and fifth price auction, you will overbid. Yes. but you're not paying the, suppose it's third party auction, third party auction, right? Overbid doesn't mean matter. Suppose I value this 10 bucks, the coffee, right? I bid 11, that's fine. If the other guy is, the next guy is bidding 9, the other guy is 7, I still get something. If overbid a little bit is fine. Because you're not paying what you're doing, you're paying the third highest one. In equilibrium, it will be overbid. But remember, overbid doesn't mean you overpay. Because you're not paying the... Overbid a little bit, that's fine. If overbid a little bit in the symmetric equilibrium. Okay? But we focus on first price, second price. So first price, you underbid. Okay? And in the first price, you overbid. Right? And that means that in the private value case, there are no win occurs. Right? Because when you win, you know you will not overpay. Right? Of course, as you said, if you do third price or fourth price, you may end up, as you said, win occurs. Right? You win, you actually overpay. That's true. But that can be part of equilibrium, right? Because you may earn a lot when things works out nicely. Okay? But the first price, second price, you never overpay. You never pay more than what you value, right? Because you decide the price, right? Kind of, right? Because first price, you pay actually what you do. Second price, you bid no more than you value, right? So basically, you cannot overpay at the end. Okay? The third price, because overbid, right? A little bit, or fourth price, fifth price, overpay, then in some cases you have a winner curse. Right? That's why you don't see third price, fourth price, fifth, right? In that sense. But anyway, let's have a break of shorter, maybe 10 minutes. We'll come back and then we continue. Don't worry, it's not very complicated.
对，那就半年。12月。可能你刚刚好。没有我想说，然后7月因为是太多了，然后一直在我就是那个10万块，然后他早上有1小时，然后可以说就是一个人，不是每个人体验是那个地方，我那个大咱们给大我们的学生的7块钱，有一个人1起3个小时。你的微啊，它是在中国的好像不上面在上面，但是你的微，好像你不是它都leverage 还是没有，leverage 没有，但是 ever 有一个 market， 所有的就是有啥？要回答那个问题。对，现在或者因为主要是就是啥？基本上不会说。像你写的书，每个人都看到一块。对啊，是因为就是我原来一次来写就没事。还没转过来，然后但是哦，这个你有没有咱们俩的脑电，我们俩就是第2天我们都收到了，然后那个就是荒谬，可以抓到的。老板以前在建国，我可以看的但有些交上去了，他们这边收对哦，毕竟今天丝毫不能生气。但是这个是比较现实的情况，会有人高。对，不好意思，我学习上面是没什么，而且我们这个是他的刚开始是开的，他不会有哪里，他就是。先抢一个，然后再到那个。我之前定这个，我说实在的，我是东北人，然后他们那边比较然后他们小时候我都该死了。东北老鸡他正东西的东北的只有南方。对，东北什么会议？但是这个有很多上网上是海南。
因为 common prior 也知道我这边，他也知道我这边有一个情况，他的那个是几个情况，对，开始你用来什么法？你有你拆了东西。对，那就是那几个拆一个，因为才8个人，你需要多少？很多没有东西。那一般来说就是我们就叫它开天差加中完全就开了这个基本上没差。这个结果取决于你的 discover 但是一个8个人的话，基本上就是谁比较 patient 的，谁就大部分谁比较谈判嘛，大概就是谁能忍嘛，对吧？这个有很大的，这个也是有这个，就是8个人是一个我研究的。
刚刚忘记左边是左边，我以为2个小人上面有一个 UFO。
Let us resume. Okay. So the payoff will be like this. Okay. So it's payoff rule. Payment rule is you have to specify how much to pay given you submit the bid, right? And that depends on the auction, right? Usually, we assume if you win, you pay. According to the rule, you lose, you don't pay anything. Okay? And in general, in mechanism design, it need not be like this. Okay? It can be you lose, you still need to pay. Okay? It happens in some of the scenario. Okay? But in our model, it doesn't have to be. But in general, you can still pay something. Okay? And it's risk neutral, so you calculate the payoff. You win, you lose. So basically, you can't care about winning. Okay. So now we look at this second price auction. Okay. And the allocation rule says the following, right? And let's assume that no one bid the same anyway. So assume no one bid the same number because the real number there, right? And if you can the same, you can just think about equal likely just roll a die. Doesn't really matter. In general, doesn't matter, but in some model it matters. But just assume if the same, they just equally allocate. Okay. And the winner only pay the second highest. Okay. The payment rule is just BJ not including I. Okay. And you lose, you get 0. So this is your payoff, right? If you are the highest bid, you get the object, you pay the second highest bid. If you are not, you pay 0. Okay. So basically, just this is a mathematical way to write it. Okay. Of course, you know the word, right? The highest bid would win. You pay the second highest price. You don't pay anything if you lose. Okay. That's what verbally it says. Okay. Why we take the time to write this? Because later, if you try to go further, you learn mechanism design or you learn further auction. That's very important to specify the payment rule and the allocation rule. Okay, but in this context, not very important. Okay, and we first argue that in this context, turn out to be we can look at twofold strategy, and we can focus on what we call Ricky dominant strategy. Okay, and if we call what is dominant strategy means regardless of what other people do, this particular strategy is strictly better than others. Okay, if you remember definition. So let's go back to definition here. How we solve present dilemma, right? Present dilemma is dominance solvable. Dominant strategy imply regardless of what other are doing, for every fixed other people's strategy, right? No matter which situation, one strategy, right, is strictly dominated if it's strict inequality, okay? And now we relax this to allow weak inequality, okay? If something that no matter what other people do is always one of the best, then we will call the weakly dominant, okay? And we say that telling the truth in second price is weakly dominant. We'll do this proof, okay? Don't worry, the proof is very simple, just look at the table. So it's the simplest proof I taught about this class, I think. So, and let's see the example, let's do the proof, very simple, okay? And before the proof, I want to argue why this is true, okay? You compare overbidding and truthful bidding, okay? And if you bid more than you think, if you lose, doesn't really matter, right? You get zero, right? All get zero at the same time. If you win, okay? If you win, you will see you probably pay more than you think that you will lose, okay? And underbid and truthful, you may forego some good opportunity there. But let me do the proof directly. So very simple. This is the proof, just a single page proof, okay? Very simple, okay? So look at this graph, okay? So your valuation, okay, can be three situations, okay? Look at all other people's strategy, other bidding, okay? Your valuation is higher than the highest bid of the other guy, equal to or less than, three scenario, right? So you value $10, okay? The situation can be other people bid $9, other people did 10 or 11, right? That's three scenario, right? More than 10, less than 10, okay? Okay, the three scenario, okay? Then we need to compare three possible strategy, okay? Put the middle one first, okay? You do the true bidding. You bid what you think, okay? If your valuation same as other, we assume that the thing is not allocated, zero, but doesn't really matter anyway. You can assume just equally share, but anyway, let's make it zero, okay? And if your valuation lower than the other, get zero, right? So let's see, right? So look at this row, okay? And if other same as you don't get anything, okay? And if your valuation lower than the other, then you, right? Other people bid $11, you get nothing, right? And but if other people bid 9, right? Then you will make $1, right? So that is the scenario. You win if other people lower than you, otherwise don't get the object, right? So you win by taking the surplus, okay? That is what you would do when you truthful bid, okay? Let's compare to underbid, which is the third row. Underbid is here. Okay? You bid below your valuation, okay? Say you bid $9, okay? If other people bid 10, the highest bid is 10 or 11, you don't get the object, right? You get zero as a result, right? You get zero here, right? And if you bid, then what happens if the other people also less than 10, okay? You only win if you higher than others, otherwise you get zero, right? But do look that the payoff is same if you win, because you're only paying the second highest, not your bid. So how much you bid doesn't really matter, right? You only pay what others said, the highest one. So how much you pay doesn't really matter. How much you pay only affect your win or lose, right? In that case. And in that case, this is better than this, right? Because you win sometime, right? Sometimes you don't win. So this is better, right? And you can similarly see that if you bid more than, you think you bid more than $10, right? If other people are less than 10, you still win, but your payoff the same because your bidding only determine your win or lose, not your payment. So you still win here. And same, you don't win. But you actually, other people bid less than 10, you bid more than 10, you win, right? But you will your payoff will be negative. Yes, because because other people bid more than 10, okay? You're paying more than $10 given you win, so you get negative payoff, right? Because the object is $10 to you, VI is 10, okay? In the third column means that other people bid more than 10, but bid 11, okay? You win means that you higher than 11, right? So you bid 12. That means that you're losing $2, right? Because actually you shouldn't win here, right? You shouldn't win this. You shouldn't win here. Every people bid more than your valuation, right? So you compare the purple and the blue, actually losing in the third column, right? You win the scenario, you overbid, you win the scenario you shouldn't win, okay? And you underbid, you lose in the scenario you should win, right? So that's only thing you should do is just tell the truth, right? So that is why telling the truth is always dominant, because you're not paying what you are bidding. Your bid only determines your win and lose, okay? So that's why the benchmark should be you're telling the truth, right? Because you only want to win is actually above, right? So that is the meaning, okay? So that means that when you do second price auction, very simple. You just think how much you value to you, then you just bid it. So that's why very often in the real world, right? Because I don't need to care about what other people think. I don't need to guess. I don't need to estimate. I don't even need to know how many people are involved in the bid, right? In this model, I don't even need to know F. What's the distribution of others? I just need to know how much I value the object, and that's it. Very straightforward. I don't need to guess how what's the N, what's the F, whether symmetric is very general. Okay, so that's why it's very strong. Of course, in finance, there's a little bit issue here. Even the second price auction, sometimes you don't want to tell because it may reveal your willingness to pay, right? By telling people how much you value the object, then you reveal the information. And that's why in US, the IPO style is slightly different from auction. It's like for the institutional investor, right? You get the object and the there's an underpricing, right? That's why they deliberately lower the price so that you get some benefit from telling them the truth. So that's why some of the reason why I explain underpricing in the IPO, but out of the scope of our class. But there's a lot of literature in finance try to explain why IPO price is always below the market price. It's because you have to give some surplus for people to join because they reveal certain kind of information to you, or that's cost of doing it. But that being said, it's way beyond the scope of our thing. But in general, this is what you see, right? So we see that in second price auction, you want to tell the truth, very straightforward. Okay? And do note in this model, there are no aftermarket, right? After you sell it, it's done. You can imagine there's a lot of literature, recent literature talk about if you have resale. I got the object, I resell again. What should be the auction format? But it's way beyond our class. But so as I said, it is weakly dominant to tell the truth. That means that everyone telling the truth is a equilibrium. right? And this equilibrium is very strong, right? Because there's very little calculation I need to do, right? I just need to say, I think it worth this to me, I bid this. No calculation, okay? So it's very strong, right? Now we look at the first price auction. The first price auction is very simple, right? Same idea here, the only difference is this guy, right? You also, again, you get the object if you're the highest bidder. The only difference is you pay this one, right? Before is you pay, look at others, the highest, okay? And now you determine how much you pay by submitting the bid, okay? So that's why the BI depend not only on how much you bid, tell you whether you get allocation, also the payment, okay? So that's why you have to be very careful with letter B. Very careful, because a strong correlation, your payoff, okay? And as I was said, the calculation is very complicated, okay? A little bit more complicated, okay? And easily you would see, as I said, you will not bid more than your valuation, right? So only focus on underbid, right? Because you overbid, then you win, you will get negative, right? So that's why I only focus on this. Okay, so as we argue, we only underbid, right? We already argued it before the proof, before the break. So in general, it's very complicated. In general, you need to solve differential equation to solve this problem. But if we assume the distribution of the value is uniform from 0 to 1, we don't need differential equation. There's a closed form solution. Okay, turn out to be very simple. How much you bid depends on your V. Okay? If you rewrite that, it's just you rewrite that. Let's rewrite that. This is just V minus 1 over N of V. Okay? The first term is just V, just you bid what you value, but you underbid by 1 over NV. Right? If imagine the simple case, N goes to infinity, right? You just bid whatever you think, right? But if there are some people there, you underbid. I will tell you why, but that is like this, okay? Now, turn out you can see this is a constant underbid in this model. Alpha is just 1 minus this fraction, okay? So we will try to prove that, okay? So turn out to be you just constant straight bidding, and alpha depend on N, right? So depend on how many people in the auction, you underbid 1 over N of your valuation, okay? And that means that before you bid, you have to guess how many people are in the bid on the auction, right? That means that you create trouble for the bidder, right? Usually, as a market design, you create trouble for them. Usually doesn't work very well in behavior, right? Because they have to calculate and they may happen to do it wrong. So better not to create trouble. But anyway, if you create trouble for them, they need to calculate. So let's do some proof quickly, okay? And the proof is very simple, and actually you generalize in a lot, okay? So the proof we do is we restrict the strategy of the bidder to this form, okay? Remember in the before, what the strategy you have is you have to find a function, right? It's a very complicated thing, right? How to optimize over a function is very difficult. So we, in the first round, you will see we restrict ourselves to choosing one parameter, alpha, a linear line, and of course we proved it's optimal, okay? But this is our first attempt, is we restrict to a linear strategy or constant strategy, just like everyone choose a parameter, alpha, okay? Of course, this is simplification, right? Because I don't allow this happen. I don't allow a curly thing, but I have to come up with a linear thing, okay? So let's assume that happened, disapprove. I do quickly, but it's just calculation, okay? So what I'm going to do is very simple. My expected payoff, okay, only comes from if I win, right? If I only win, I'll pay off. If I don't win, I have 0, right? I win, this is my valuation, and this is my bid, right? I win, this is my net surplus. I only win if my bid is higher than others, right? So that's the probability. Clear? Okay? And because I assume everyone use the same alpha, right? So BJ, the other guy, is just alpha J. Suppose I only have 2 bidders, okay? The other J, right? Only put alpha J. Okay? I focus on symmetric equilibrium, okay? And I rewrite this alpha J is rewrite the B over alpha, right? And the other guys is I have prior is uniform, right? It's just BI over alpha, right? From 0 to 1, right? Remember, VJ is from 0 to 1, right? You know your VI, right? But I don't know VJ. VJ is from 0 to 1. So 0 to 1, uniform with this guy, right? So that's the main part, right? But from here now it's very simple. Your payoff is contracted in B, right? You just bid half of that. So if you only 2 bidders, you assume uniform, just bid half of your value. A lot on the bid, right? You just don't, you think $10, bid $5. Okay? Now, you can easily generalize this to more than 1 bidder. Very simple. Okay? If you more than 1 bidder, just do this, right? Because independent assumption is just raise to the power n minus 1, right? Because only care about the largest, right? And largest means everyone is more than that value, right? So that's why you can simplify to that. Okay? Suppose 2 bidders, right? You have to higher than them to win, right? So that's why the same thing, right? Only as long as your bid is higher than all of them, then you win, right? Independent, you just this multiply, raise to the power n minus 1. Okay? And that explains this is one of the solutions, right? But of course, you probably need to go to further to do a more general proof. Okay? This general proof is very simple. Don't worry about it. It's very simple. The same idea. Instead of looking at alpha, as long as it's not alpha or V, you just assume there's that's very often assumed in the literature is you have a strictly increasing function of V. That's a proof. It's very simple. Don't worry. The technique is almost the same. Okay? You just say your valuation is, your bidding is increasing function of valuation. Okay? That's a one-to-one thing that makes things very simple. So basically the same logic here. You just replace the bid by function of their valuation, right? Because it's one-to-one mapping, you can inverse it, same result, right? There's nothing new there, right? And the only troublesome for this method, when you go a little bit further, is when you differentiate, you become a crazy object. Okay, I don't want to go over that, but you have crazy object, and you need to use inverse function theorem to come up with this differential equation, right? Because it involves differential, right? And in general, this is not solvable. Okay, and it's not closed form solution, but I don't want to go over detail, but by some fundamental calculus, you get the same thing. Okay, I'm not going to go to detail because unless you do this, there's no use of doing this kind of model. But if you look at it, it's not complicated. Okay, don't worry, just simple. In this case, it's a simple thing, but in general, it's very difficult. Okay, but anyway, turn out that this is very general. Okay, I'm not going to show you the proof, but trying to show you that the assumption of constant bidding is very general. But regardless of what, I want to tell you that this kind of restriction is very commonly easily seen in the literature. When you talk about base net equilibrium, okay, accelerated finance, you don't know how to bid. You assume that people always bid proportional to their valuation. So this is very common. They call linear equilibrium. So we often see that in a lot of paper. Of course, in this model, turn out that this is true, okay? And there are no other better equilibrium, okay? But in general, this is only part of equilibrium. You have nonlinear equilibrium. But in apply, which mostly you do in order free theory, this is the most common one. Okay? And that's what we get. Last slide. Talk today. I will leave the double auction next week. Okay. So this is very simple. Okay. We will see the second price auction is V, and first price auction is this one. Okay. And this amount will be decreasing with N. Okay. And I didn't put the proof here. You can actually prove, okay, given this strategy, right? You can calculate the revenue of the auctioneer, right? You know how much they bid, right? And you can show that whether you do second price or first price, same. So as a bid, as an auctioneer, you don't care about first or second price, in theory, right? But you know that you don't want people to calculate, right? Because whether people will enter into auction depend on whether they find it easy or difficult, right? Because if too difficult, I don't want to do it, right? Many people is very behavioral. So that's why the recommendation is you would do the second price auction, right? In that suggestion, right? That means that you do. That's why you see a lot of time you have English auction, right? You see the price from 0 to above, right? Not the Dutch auction from very top go down, right? Because easier to think, right? You don't want to take the risk. But I guess I end here because our TA will do the CTE. Okay. So any more question? So I hope you stay around to do the CTE, or you can do it at your home. But I will leave this room. I will see you if this Wednesday we have makeup class doing contract theory. Your record is makeup, so it doesn't really, as I said, auction is not included in the exam. So nothing after this class will be an exam. So it's optional. Okay. So I see you Wednesday. If not, I'll see you on next Monday. Okay. Next Monday, same time, but different venue. Okay. So bye bye. Thank you for this class. If I don't see you in all the makeup classes, hope you enjoy. Thank you for coming. Bye bye.